the question that we had was solve the following LP, that is linear programming problem, by simplex method. This was the statement, and we had numerical maximize z is equal to 12x1 plus 16x2 subject to uh, the constant 10x1 plus 20x2 less than or equal to 120, and 8x1 plus 8x2 less than or equal to 80, and they have given x1 and x2 greater than or equal to 0, right? So let's start with the problem. Firstly, you have to observe the problem and see whether it is given in the standard format, right? So yesterday we have already seen what is the standard form. That is, the decision variables are non-negative, that is x1 and x2, which are the decision variables, are non-negative. And even we have to check whether the right hand side of your constraints are non-negative. So my this RHS of my constraint and this RHS of my constraint is non-negative. So if so, no, again the one more thing is that the constraints are expressed in the equation format, right? So my constraints are also given in the expression format. So we can say this is given in the standard form, right? So if this standard form is not given, you have to firstly convert it into the standard form, and then you'll have to try solving this numerical. So now that it has been given in the standard form, our first step is to frame the simplex problem, right? So what is the framing of the simplex problem? As of now, it is the consideration of the slack variables, right? So I have initially my objective function as maximize z is equal to 12x1 plus 16x2, and no, my constraints are subject to. So now what I am going to do here, I am going to consider the slack variables in the uh, constraints. So it is 10x1 plus 20x2 plus s1. Now that I've considered this slack variable, the inequality sign can go, and now it is equal to 120. Similarly, the other constant that I have is 8x1 plus 8x2 plus s2 is equal to 80. Right? Now that I've considered slack variables in my constraint, I should also consider it in the objective function, but the slack variables do not have any significance in the objective functions, hence their coefficient will be 0. So here it will be 0 s1 plus 0 s2. Now the variables that I have with me are 4, that is 2 decision variables and 2 slack variables, and all these variables should be greater than or equal to 0. And my last constraint x1 comma x2 comma s1 comma s2 should be greater than or equal to 0. Hello? Yeah? Sir, थोड़ा देर बाद कॉल करो, आई एम इन अ लेक्चर. Okay, thank you. Sorry. So here it is. Now that we have got the simplex problem, now that we have framed the simplex problem, we can move ahead and we can frame the initial simplex table. So framing initial simplex table, right? I'll be telling you how to frame the initial simplex table, and then we can move forward. right? So here we are going to write Cj, which denotes that it is the it is the coefficient of the variables in the objective functions, and we are going to write here b dot v, that is nothing but the basic variables. It is the short form for basic variables, right? So because of the space constraint, I have written it's bv, but you can write it as basic variables as well. So in objective function, sorry, in objective function, we have four variable x1, x2, s1 and s2, and the coefficient of them we are going to write here. So the coefficients are 12, 16, 0 and 0. Here we are going to write it as solution, right? So now we are going to write here as CB, which is known as coefficient of basic variables, and the basic variables that we are going to start with in the initial simplex table is always the slack variables. So slack variable s1 and s2 that we are going to start with, and that particularly we have to remember. So this is how we are going to start with the table. Now the coefficient of the slack variables here are 0 and 0. So 0 and 0 I am writing here. So now we were talking that yesterday that we are going to start with the origin as one of the corner point. So the origin has the coordinates at 0 and 0. So we have it as 0 and 0 here, and then we are going to start with the s1 and s2 as a slack variable. So 0 0 is the coordinates for your origin, right? So now let's begin. We have to represent our constraint number 1 and constraint number 2 in this simplex table. So consider our first constraint. So here x1 has a coefficient of 10, so I'll be writing it here as 10. X2 has a coefficient of 20, so here it will be 20. S1 is having the coefficient as 1, and S2 do not have any coefficient, so it will be 0. The solution is nothing but 120, which is the digits after is equal to sign, right? Similarly, when we move ahead, we are going to consider second constraint. So coefficient of x1 is 8, x2 is 8, coefficient of s1 is 0 and s2 is 1. The solution here is nothing but 80, right? Now what we have to do is, now we have to calculate zj. Zj is nothing but the addition of the multiplication of CB and the corresponding coefficient. So I'll be telling you how we are going to write find out Zj. So Zj for first, so the value of Zj for your first column can be found out. So it is 0 0 into 10 plus 0 into 8, right? So 0 into 10 plus 0 into 8 is equal to 0. Similarly, the next value will be 0 into 20 plus 0 into 8, right? So again it will be equal to 0, right? The next zj we can calculate is 0 into 1 plus 0 into 0, right? So 0 into 1 plus 0 into 0 will be again equal to 0, and likewise we'll be getting the value as 0 only. Just a second. Hello, PCCOE research. Sorry. So no, the firstly we are going to find out the zj values, and no, particularly the zj values as the coefficient of your basic variables is c it is a zero only. So what you will be getting it as only the what you'll be getting is zero only at this particular stage. So don't generalize it. Just remember the process that we are going to follow. Even for the solution, you can carry out it. 0 into 120 plus 0 into 80 will fetch you zero only here, right? So now that we have completed this, what we can do is we can find out firstly we have to check whether this is an optimal solution or not, right? So for optimal solution here, for maximization, to be for this to be a optimal solution, so for maximization, all cj minus zj values should be less than or equal to 0, right? So this is the condition for maximization. So all cj minus zj values should be less than or equal to 0, and for minimization it will be all cj minus zj values should be greater than or equal to 0. Right? So which is this problem? This is a maximization problem. So we are going to follow this particular condition which says that all cj minus zj values should be less than or equal to 0. If so, the solution that is obtained is optimal. So we are going to find out cj minus zj values. So if we find out cj minus zj values, so what is cj? It is 12. 12 minus 0 is equal to 12. 16 minus 0 is equal to 16. 0 minus 0 is equal to 0, and 0 minus 0 is equal to 0. So here if you see the cj, all your cj minus zj values are greater than or equal to 0. But no, we do not know, as this is the maximization problem, we require all cj minus zj values should be less than or equal to 0. So here all cj minus zj values are not greater than or are not less than or equal to 0. So hence iterate further. Hence iterate further. Right? So we have decided to iterate further on the basis of the optimality check. For maximization, it is all cj minus zj value should be less than or equal to 0, and for minimization, all cj minus zj value is to be greater than or equal to 0. Now it means that no, S1 and S2, that particularly S1 S1 and S2, these basic variables do not particularly give you the optimal solution, right? So we'll have to go for some different solution. So what we'll have to do is either we'll have to replace S1 or S2 with the basic variables as X1 and X2, right? So S1 and S2 here, S1 and S2 are not helping us, right? So either we'll have to introduce our basic variables X1 and X2 into this, and then we'll be getting the optimal solution. So firstly, we'll be doing it stepwise. So firstly, we'll have to decide whether which of the basic variables that we have as of now are to be replaced, right? Now what we are going to do is we are going to consider the maximum value amongst the cj minus zj values. So if you see the among cj minus zj value, 16 is the maximum value. So I'm going to draw arrow here which says that this is the incoming variable, and this arrow is across my x2 variable. So my x2 will be the incoming variable, but now it is an incoming variable, but from S1 or S2 we'll have to replace either of these two variables so that this place for X2 can be made. So right, so this particularly the arrow I have shown, and I'm going to mark this particular entire column. So this column is called as a key column. It is called as a key column, right? So now I'm going to draw this table again so that we do not make any confusion, and it is very easy to it becomes easy to understand. So just give me few more minutes. few more seconds so that I can repeat this table properly. Okay, so we had this table previously. So what we have done is we have chosen the maximum value of amongst the Cj minus Zj. So this is that value, right? And what we have done, we have marked this column. So this is now our what key column, right? Now amongst S1 and S2, we have to select whether which of the variables is going to replace, and at that place we are going to add our variable x2, right? So now that we have to decide with the help of a new column that is called as a ratio, right? So it is the ratio of the solution divided by the coefficient of the key column. So that is nothing but 120 divided by 20. So this is 120 and this is nothing but 20, right? So 120 divided by 20 is equal to how much? It is equal to 6, right? Nextly, it will be what? It will be 80 divided by 8. So it is 80 divided by 8 and is equal to how much? It is equal to 10. To select a variable that is going to leave, so it is called as a leaving variable. So x2 is our incoming variable, right? And one of the variable will leave, and that particular variable is called as a leaving variable. So which of the variable is going to leave? The variable which is smallest among the ratio is going to leave, right? So which is smallest among the ratio, so it is 6 and 10. So 6 is the smallest, of having the smallest value. So this particular variable is going to leave, right? And hence this particular column, sorry, hence this particular row is now called as a key row, right? So we have S1 as a variable which is going to leave, right? And we have the X2 as a variable which is going to enter, right? So I'll be just writing here. So for key column, that is entering variable, select max value amongst Cj minus Zj values, right? And for key row, that is leaving variable, select minimum value amongst ratio values, right? So key column, it is representing the entering variable, max value among Cj minus Zj values. Key row, it is going to represent leaving variable, and it is the minimum value amongst the ratio values. Right? So I'm hoping that you have got this. It is very easy to remember. Now your 20, if you see a 20 is nothing but an intersection of key row and key column, and this 20 is called as a key element. So this is nothing but your key element. Right? So this is nothing but your key column, and this is nothing but your key row. I'm hoping that you have understood this terminologies, and because we are going to use them for next iteration. So now what we are going to do, we are going to perform the next iteration. Right? So just a second, I'll be requiring a fresh page for this. So I'll be again drawing the above table on the next thing, and then we can move ahead. Just give me a few more seconds to complete this page. It was S1, S2, here it was Cj, basic variables, x1, x2, s1, s2, here we can write solution, and here it is ratio. So it is 12, 16, 0, 0. Here we have 10, 20, 10, 120, and here it was 6. Here it is 8, 8, 0, 1. Here it was 80, and here it is 10. So it is 0 and 0 here. Zj, Cj minus Zj, it is 0, 0, 0, 0, 0. And here it is 12, 16, 0 and 0. So we have decided this is our leaving variable, this is our entering variable, this is our key column, this is our key row, and 20 is our key element. So we have to now that we have decided that all Cj minus Zj values are not less than or equal to 0, hence iterate further. Right? So iteration 1. For iteration 1, what we require is the new table again. So we'll have to reframe the table, but very wisely. There are some calculations that are involved, and I'll be making sure that you understand those calculations as well. Right? So just a second. See, the ratio column is to be added only if the optimal solution is not opted. If the optimal solution is opted, there is no need of ratio column. So I have not drawn ratio column as of now. X1, X2, S1, and it is basic variables that we need to write here. So this is X1, this is X2, this is S1, this is S2, this is Cj. All this will remain same only, 12, 16, 0, 0, because objective function is not going to change, right? So now the change that I'm going to tell you is here. The coefficients in the table will now change. Now we have said that here S1 is the variable that is going to leave. So instead of that, which variable is going to enter? X2 variable is going to enter. So instead of S1, write X2, and S2 will remain as it is. So here the S2, the coefficient of X2 is what? Coefficient of X2 is 16. So we are going to write 16 here, and the coefficient of S2 is 0 only. So that 0 will go and it will be written appropriately. Now what is to be done for key row, right? So I'll be writing here key row. What you are going to do is, here we'll have to find out Cj. So Cj minus Zj also. Now I'll be writing here. So for key row, new values, what will be the new values? New values will be is equal to previous values divided by key element, right? So the previous values divided by key element. PV stand by for the previous values. So if you see here, we have the value 10, right? So here you can see this value is 10 in our key row. So 10 divided by what is a key element? It is 20. So 10 divided by 20 will be what? It will be 1 by 2. So we'll be writing it 1 by 2. So it is it is expected that you do not write the values in the fraction in your simplex table, or a coefficient in the as a coefficients in your simplex table. So always write it in the fraction format. So it will be 1 by 2. Nextly we have 20 divided by 20 only, so it will be 1. Nextly we have this 1 divided by 20, so it will be 1 by 20. Nextly we have 0 divided by 20, so 0 divided by 20 is 0. And nextly we have 120 divided by 20, and it is nothing but 6. Right? So I'm hoping that you have got how to obtain the new values in key row. Right? So for other rows now, for other rows, new value is equal to old value minus corresponding key column value into corresponding key row value divided by key element. So this is a very simple formula, though it may appear to be a bit complex, but it is, when I will be telling you or you will be practicing, this formula doesn't require any mugging up, and it is very easy. So right, so it is old value minus, so your new value is equal to old value minus corresponding key column value into corresponding key row value divided by key element. So I'll be telling you in the form of some calculation here as well. So now we are going to find out the new value of 8 here, right? So this is the 8 value that we are going to find out. So what is the old value? The old value is 8 minus what is the corresponding key column value. So for 8, the corresponding key column value is what? Key column consists of 20 and 8. So key column value will be what? It will be 8 into what will be the corresponding key row value? It will be this particular value, which is 10, right? 10 divided by what is the key element? It is 20, right? So for this particular space, I have got this particular formula, right? So for 8 minus 8 into 10 divided by 20. So if you do this particularly, so what will be the 8 into 10 will be what? 80. 80 divided by 20 will be 4, and 8 minus 4 will be equal to what? It will be equal to 4. Similarly, if I have to go for the next now, so now for next 8, the old value is 8 only. 8 minus. Now here this 8 is itself here itself we have a key column. 8 is also the part of your key column only. So the key column value again here will be 8 only, and corresponding key row value will be what? It will be 20, and again it will be divided by 20, right? So it is key element. So 20 cancel. 8 minus 8 will be equal to what? it will be equal to 0. If you move ahead and try to solve, try to find out the value of new value of this for 0, so it will be 0 minus, just a second, I'll be using this space, so it will be 0 minus corresponding key column value is 8, corresponding key row value is 1, right, and a key element value is 20. So it will be what? It will be it will be 8 by 20, minus 8 by 20. But minus 8 by 20 can be written as minus 2 by 5. So it will be minus 2 by 5, right? Similarly, for next value, which is 1. So for 1, I can write 1 minus. So here it will be 0 into, it will be 0 into 8 divided by 20. So 0 into 8 will be 0, 0 divided by 20 will be 0. So the value will remain as it is, which is 1, right? Now for our next value, which is 80. So for 80, it will be what? It will be 8 into 180. So I'll be writing here as well, 80, 80 minus 1 into, I don't have space here. So I'll be writing here, 80 minus, it will be what? It will be 80 minus 8 into 120, 8 into 120 divided by 20, right? So 20 here, it will be 6, 8 6 are 48, 80 minus 48 will be equal to what? It will be equal to 32, right? So I'm hoping that you have understood that how you have got the key, how you have got the new values, right? Let's move ahead and check whether this is an optimal solution or not, and then let's see what we have to do. So now you can see that Cj, so we have to find out Cj. What is Cj? It will be 16 into 1 by 2 plus 0 into 4. So 16 into 1 by 2 will be what? It will be equal to 8. Similarly, for next value, 16 into 1 plus 0 into 4. So 16 into 1 will be equal to 16, right? Nextly, 16 into 1 by 20 plus 0 into minus 2 by 5. So 16 by 120 will be equal to 4 by 5. And lastly, 16 into 0 plus 0 into 1 will be equal to 0 only. We can move ahead. 16 into, you can find out 16 into 6 as well. So what is 16 into 6 plus 0 into 32? You can tell me. 16 into 6, sorry, 16 into 6 will be equal to your 96, right? So now that we have to find out whether it is optimal or not. So optimality check is related with Cj minus Zj. So let's find out. 12 minus 8 is equal to 4. 16 minus 16 is equal to 0. 0 minus 4 by 5 is equal to minus 4 by 5, and 0 minus 0 is 0, right? Here also we can say all, sorry, I won't be writing here because this we require. So all Cj minus Zj values is not equal to 0, and hence is not not less than or equal to 0. Hence we'll have to find out the ratio, and we have to find out the key row and the key column again, right? So for this thing, what we'll have to do is, for finding out, firstly we find out key column. So for key column, we need to find out the maximum amongst the Cj minus Zj values. So it is equal to this particular column, right? And we are going to highlight this column. All right. So now we are going to find out the ratio. So ratio is nothing but 6 divided by 1 by 2. So 6 divided by 1 by 2 is equal to 12, and 32 divided by 4 is equal to 8. So we have to find out what is the leaving variable. So minimum value amongst the ratio is 8, and hence this will act as a leaving variable. And I'm also going to highlight this particular row, which is called as a key row, right? So we have now got key column, key row, and here you can identify the key element is here the key element is 4, right? So let's do further iteration and then we can stop in this lecture. So I'll be again drawing this particular table again, so that there won't be any confusion. So just give me another couple of seconds, and we'll be moving ahead. Just a minute. One, two, three, four, five. We had a ratio and solution column as well. CB, CJ, basic variables x1, x2, s1, s2, 0, 0, 12 and 16. So this was solution, this was ratio, right? So it was 16, 0, x2, s2, 1 by 2, 4, 1, 0, 1 by 20, minus 2 by 5, 0, 1, 6, 32. We have found out the ratios as well, 12 and 8. So it was zj, cj minus zj, 8, 16, 4 by 5. Here it was 0, and here it was 96. So 4, 0 minus 4 by 5 and 0. We have all cj minus zj values are not less than or equal to 0. Hence iterate. Right. So iteration 2 we will be doing short time. So it is the key column, it is the key row, and the key element that we have is 4, right? So again moving ahead, so if we see CB, so we have 1, 2, 3, 4, 5, right? So this for basic variables. Cj basic variable x1, x2, s1, s2. So it is 12, 16, 0, 0. Here it is solution, and we have to find out some new values, right? So now you can see x2 is going to remain similar. S2 is the leaving variable, so instead of that x1 is entering. So x1 we are going to write, the variables are 16 and 12 that we already know. So for key row now, so for key row, which is the key row? So here this is the key row. So for key row, we have already seen what are the elements it will require. The key, the new values that we are nothing but we have to divide old value by key element. So 4 divided by 4 will be 1, 0 divided by 4 will be 0, minus 2 by 5 divided by 4, yeah, anyone minus 2 by 5 divided by 4 will be equal to minus 1 by 10. Here it will be 1 divided by 4, and 32 divided by 4 is equal to 8. Right now here similarly we are going to find out a new values for the non-key rows. So for here it will be I'll be I'll be using the space here. So it will be 1 by 2 minus 1 by 2 into 4 divided by 4. So 4 cancel, 1 by 2 minus 1 by 2 comes out to be 0, right? So for next thing you can write 1 minus, it will be 0 into what is 0 is the corresponding key row value, and what is the corresponding key column value? It is 1 by 2 divided by 4. So 1 minus this entire will be 0 only, so the answer will come out to be 1 here. Similarly, if we go ahead and we find out, so 1 by 20 minus, so here it will be minus 2 by 5 into 1 by 2 divided by 4. So if you do this entire operation, so you'll be getting this value as 1 by 10, right? Nextly, for the last thing, it is 0 minus, no, it will be 1 by 2, 1 by 2 into 1 divided by 4. So the value comes out to be minus 1 by 8. So for the solution as well, you can do it 6 minus, it will be 32 into 1 by 2 divided by 4. So if you find out this particular value, the value comes out to be 2, right? So now we have to find out all these zj values. So 16 into 0 plus 12 into 1 comes out to be 12. Next is 16 into 1. Now into 16 into 1 plus 12 into 0 comes out to be 16. Next, if you do 16 into 1 by 10 plus 12 into minus 1 by 10, it will be coming out to be 2 by 5. Now nextly 16 into 16 into minus 1 by 8 plus 12 into 1 by 4. If you do, it will be coming out to be 1. And nextly 16 into 2 plus 12 into 8. So that is 32. And it comes out to be 128. So I have to find out Cj minus Zj values. So it is 12 minus 12 comes out to be 0, 16 minus 16 comes out to be 0, 0 minus 2 by 5 comes out to be minus 2 by 5, and 0 minus 1 by 4 comes out to be minus 1 by 4. Yeah, so it comes out to be minus 1 by, no, it will be 0 minus 1, no, so it is minus 0 minus 1 will be minus 1, sorry. So it will be minus 1. So here if you see, all Cj minus Zj values are less than or equal to 0. Hence optimal solution. Hence optimal solution. Now how to identify optimal solution? That is okay, we have identified. So but the problem was we have to find out Z max value, as well as we'll have to give x1 and x2 value. So what will be the value of x1? The value of x1, the value of x1 is nothing but 8. The value of x1 is nothing but 8. The value of x2, value of x2 is nothing but 2. And your Z max is nothing but 128. So this is the final answer that you are going to get. So the x1 value is nothing but your 8, and your x2 value is nothing but 2, and the Z max value is nothing but 128, and that finishes your entire numerical. Z max